Hi, welcome back. It's been a long journey with gRPC, and we've learned so much about amazing feature of it. However, we all know that gRPC is not a tool for everything. There are cases where we still want to provide a traditional RESTful JSON API. The reasons can range from maintaining backwards compatibility to support programming languages or clients not well supported by gRPC. But coding another API for REST is quite time-consuming and tedious. So, is there any way to code just once, but can provide APIs in both gRPC and REST at the same time? The answer is yes. One way to achieve that is to use gRPC Gateway. gRPC Gateway is a plugin of the protocol buffer compiler. It reads the protobuf service definitions and generates a proxy server, which translates a RESTful HTTP call into gRPC request. All we need to do is a small amount of configuration in the service. And that's what we will learn in this video. This is the GitHub page of gRPC Gateway. I'm going to use this latest version, which is version 2. You can read its documentation in this page. Before start coding, we have to install some tools. First, the proxy gen gRPC gateway. We copy this GitHub link and run go get in the terminal. One cool thing about gRPC gateway is it also generates Swagger files for us to create API documentation. So let's install this proxy gen Swagger tool as well. Alright, now if we look at the Go bin folder, we can see the proxy gen Swagger and proxy gen gRPC gateway executable binary. The next thing we need to do is to add a google.api.http annotation to the proto files. There are a lot of things we can config. You can check out this a bit of everything proto file to read more about them. For now, I will show you the most basic configuration. As is clearly written here, to have the Google API HTTP annotation, we have to copy the third-party protobuf files to our project. They're already included in the gRPC gateway library that we've just installed. So let's open the terminal and go to this folder. Go, package, mode, github.com, gRPC ecosystem, gRPC gateway. The version we are using is version 2 alpha 2. Here we can see the third-party folder. Let's open the third-party Google APIs folder. Inside it, there's a Google folder. Let's copy it to our PCBook Golang project. Okay, so now we have the Google folder here. It has one API folder, contains the proto files for the HTTP API, and one other folder for the RPC. With this in place, we can now add annotation to our service proto. Let's start with the auth service.proto. First, we need to import Google API annotations.proto. Then inside the login RPC, we add this option, google.api.http. And we declare the root with method post. And the path is v1 auth login. Since this is a post request, it should have a body. So we add body star here. Alright, now let's do similar thing for the laptop service.proto file. First import Google API annotations. Then add the Google API HTTP option to the create laptop RPC. It's also a post request, but the path should be different. I'm going to use v1 laptop create. Next, the search laptop RPC will be a GET request, and the path is v1 laptop search. Similarly, the upload image RPC will be post v1 laptop upload image. And finally, the red laptop RPC will be post view1 laptop red. Okay, the proto files are updated. Now we have to update our makeGen command to instruct protoc to generate gRPC gateway and Swagger files for us. We use this gRPC gateway out option to tell protoc to generate gateway code to the PB folder, which is the same folder that our gRPC code will be generated to. Then we use the Swagger out option to tell protoc to generate Swagger files to the Swagger folder. Let's create that Swagger folder at the root of our PCBook project. Okay, now let's open the terminal and run makeGen to generate the code. Oh, we've got many warnings about deprecated use of Go package option without full import path. Looks like the new version of protocol buffer requires Go package option to specify the full Go import path for the file. We can fix it by changing our Go package option to .pb as it suggests here. So let's copy this one and paste it to all of our proto files. The path looks a bit weird, but basically it means that the import path will be a subpackage pb of our current PCBook package. Alright, let's run makeGen again. Now we already got two warnings about protoc GenGo generator package being deprecated. I think that package is still being used by one of our tools, but for now, let's just ignore it and focus on our implementation. As you can see here, in the PB folder, two new files has been generated. First, the authservice.pb.gw.go file for the authentication service. It has a function to handle the post-login request. Note that this register authservice handler server function is used for in-process translation from REST to gRPC. It means that we don't need to run a separate gRPC server to serve requests from REST server via network call. Unfortunately, at the moment, in-process translation only supports unary RPC. For streaming RPC, we must use the register authservice handler from endpoint function, which will translate the incoming RESTful request into gRPC format and call the corresponding RPC on the specified endpoint. The contents of the laptopservice.pb.gw.go file is similar. You can check it out by yourself if you want. Now in the Swagger folder, there are many generated Swagger files, but we only care about the authservice.swagger.json and the laptopservice.swagger.json files. These files are very useful for us to create API documentation. We can easily do that by going to swagger.io, log in, then click Create New, and choose Import and Document API. Click Browse, and select the authservice.swagger.json file, and click Upload. Enter the name and version of our API. Oh, looks like it doesn't allow space in the name, so let's change this to just PCBook auth service, and click Import Open API. Voila, we have a beautiful API documentation for our auth service. This is the login route. The request body is a JSON with username and password. The successful response will have a status code 200 and a JSON body with the access token, or the error response will contain these fields in the body. It looks great. So let's upload the Swagger file for the laptop service as well. Here's the laptopservice.swagger.json file. Click Upload File, then change the name to PCBook Laptop Service. Update version to 1.0 and click Import Open API. Cool, we have the documentation with 4 routes: create, read, search laptop, and upload image. This create laptop API is a post request with a very long JSON body. Then the read laptop API is also a post, but the request body is a stream input. The search laptop uses method get. As you can see, all filtering conditions are presented here as query parameters. Alright, we will come back to this later. Now let's get back to the code to implement the REST server. First, I will refactor the existing code of the gRPC server a bit. Let's define the function to run gRPC server. Then move this block of code to that function. The function will need several input parameters. First, the auth service server, the laptop service server, the JWT manager, whether we want to enable TLS or not, and finally a net.listener object. This line is too long now, so I will break it down to make it easier to read. Now this enable TLS variable is not a pointer anymore. And here we don't need to write a fatal log, but we can just wrap the error and return it. Then we should move this listener creation block out of this function. Let's paste it back to the main function. Finally, we just return gRPC server.serve listener here. And the run gRPC server function is done. In the main function, we just call run gRPC server and pass in all required arguments and check the return error. If it is not nil, we write a fatal log. Now the REST server is gonna need similar input arguments, so I will just duplicate this function signature and change the function name to run REST server. First, we call runtime.new server mux to create a new HTTP request multiplexer. You should check to make sure that the correct package is imported. It should be gRPC gateway v2 runtime package. Okay, then we create a new context with cancel. Call d for cancel to avoid leaking memory. Now let's start with the in-process translation from REST to gRPC. We call pb.register auth service handler server function. Pass in the context, the multiplexer, and the auth service server object. If error is not nil, return it. Let's do the same thing to register the laptop service server. Then let's write a log here saying we are starting a REST server at this address with this TLS option. I'm going to add this log to the run gRPC server function as well and change the message from REST to gRPC. Okay, now we check if TLS is enabled. Then to start the REST server, we call http.servetls with the listener and multiplexer. We also need to pass in the path to the server certificate and private key file. So I will go to the load TLS credentials together. Let's define a constant for the server certificate file. Then another constant for the server's private key file. And a constant for the client CA certificate file too, to be consistent. Okay, get back to our run REST server function. We can now pass the server certificate and private key file to this function. If TLS is not enabled, we simply call http.serve with the listener and multiplexer. And that's it. Oh, there's a warning here because I forgot to put the parentheses here to call the string function. Let's fix this one as well. And we're done. The REST server is ready. Now in the main function, let's add one more flag to get the server type from command line argument. It can either be gRPC or REST, and the default value is gRPC. Then here we check if the server type is gRPC, then we call the run gRPC server function. Else we call the run REST server function. Alright, to test this server, we should add one more command to the make file. This command will start the REST server, So let's call it make rest, and I'll use a different port for it. Let's say 8081. Okay, now let's run make rest in the terminal. As you can see, the REST server is started on port 8081. Now let's open our Swagger page of the authentication service and copy this login path. I will use Postman to test the API. Click this button to create a new request. Change the method to post. Paste in the login path and set the root URL to HTTP localhost 8081. This is a JSON request, so in the body tab, we choose raw, then type JSON. Let's go back to the Swagger page and copy this example body string. Paste it in the form. We can get the username and password from the code. I'm going to use the admin1 user, password secret. Then click send. Yay, we've got 200 OK status code and the access token in the response body. So it works. If we change the username to admin2 for example, and click send again, we will get 400 not found status code and an error in the body, incorrect username password. Now keep in mind that only the REST server is running since we are using in-process translation, and because of this, it only works for unary request. Let's see what happens if we try to call a streaming request. I'm going to open the Swagger page of the laptop service and copy the search laptop request path. To remind, this is originally a server streaming RPC, so let's paste it to Postman. Okay, now the filtering parameters. First, the max price, 5000. Number of CPU cores, 2 cores. Mean CPU frequency, 2.0 GHz. Mean RAM value, 3. Mean RAM unit, gigabyte. Now click send. This time we've got 501 not implemented and the error message saying stream calls are not yet supported in the in-process transport. If we open the generated code, there's a link to an issue on the gRPC gateway repository to request for streaming support in the in-process transport. However, typically, we just use one request response mechanism in a normal RESTful call, so it makes sense to just convert unary RPC to REST. But if we really want to convert streaming RPCs, we could also do that by using gRPC gateway as a proxy. The register auth service handler from endpoint function is used for this purpose. So let's update our REST server code a bit. I will comment out this in-process call and replace it with register auth service handler from endpoint. We need to pass in an endpoint of the gRPC server, so let's define it as an input parameter of this function. Since this is a network call, we also have to provide a dial options object. Let's declare this gRPC dial options up here. To be simple, in this tutorial, I'm just gonna use grpc.withInsecure. Okay, we have to do the same thing to register the laptop service handler. Then in the main function, let's add a new command line argument for the gRPC endpoint and pass it in the run REST server function call. Finally, we have to update our make rest command to pass in the address of the gRPC server, which should be at localhost port 8080. Okay, let's test it. First, we run make server to start the gRPC server on port 8080. Then, on another tab, we run make rest to start the REST server on port 8081. Now go back to Postman and send the search laptop request. This time we got 200 OK status code. The body is empty because we haven't created any laptops yet. So let's open another terminal tab. and run make client. Now 3 laptops are created. Let's send the search laptop request again. Here we go, some laptops are found. As you can see here, there are 3 separate JSON objects, not an array. The reason is because this is a stream result, so the server sends the JSON body as a stream of multiple separate JSON objects. And that's all I want to share with you in this video. You can try to play around with other types of gRPC, such as client streaming or bidirectional streaming if you like. I hope you find gRPC Gateway interesting and useful. Thanks a lot for watching, and see you guys in the next videos.